All right. Hello, everybody. Welcome to the very first webinar, we'll say, after the SolidCAM World 2023 held in Istanbul. And every one of you who already watched the day one and day two of that, I think it was a great event. And there I had a great opportunity to show you what is in SolidCAM 2023, and many of you were very interested to figure it out how to do fixtures in SolidCAM 2023. And back then I promised that after the EMA exhibition we are going to launch it, and here we go again today. I will show you. It will be, let's say, as it is a very first webinar, we might have part 2, part 3 maybe in the future. I'm going to show you everything from the ground, how to develop this, how to do some things how we used to do it in the past. We changed some of the things, and how you can now build the library for the Chucks, Vises, Collets, and etc. I will start with the milling application. As you can see in front of yourself, I have prepared fairly simple part. And just to remind you about, from just flashback for the SolidCAM 2022 and earlier versions, you probably remember that we had 3 options available. Like you could define, let's say, 3D jobs. There were also options for the 2D, and there was also like 3D model. And this was fair, it was good, I like it, but the only thing that really bothers me, I wanted to particular fixtures, reuse them from project to project. So I wanted to have kind of a list of all predefined fixtures. I would like to reuse them from project to project and not define them all over again. And in 2023, we worked hard to all of these to push towards the toolkit. As you know, toolkit is not only for tools, it is a great platform, and it will be in the future. Everything connected to a SolidCAM development will be more or less connected to a toolkit, and it is a great platform where you can store also your fixtures. So let's start from, as I promised, I'm going to start with associative fixture. Then we will go towards the Vise, and also then the Chuck. And of course, if someone wants, I will also explain how to do a Collet Chuck. Now, associative fixture, for all of you, it's basically what we had in the previous versions when this was selected as a 3D model right in your CAD environment. And over here, I have a part on which I already have predefined fixture, as you can see it over here. So majority, unrelated if this is a milling application or mill turn application, you could insert your fixture in your project and select it as a fixture. So let's see how that is done today in 2023 release. I'm going to open a setup, and for this example, I'm using the Haswim C1000, as you can see it over here. And as standard, my part is right in the center of the table. The very first peak, I'm going to close this. You have now a little bit different machine setup. You probably have seen from these presentations in what's new that we have changed a little bit of setup. It's not a dramatic change. I think it's more user-friendly than it was used before. And the biggest change is actually here in this icon over here, as you now have a direct access towards the toolkit. You can also access it in the old-fashioned way by going over here and these 3 dots. It will also open a toolkit. But the easiest way to define associated fixture is to have a new option available in 2023. It's called Pick from CAD. When you click on that, it will directly go to a menu which are you all familiar with, where you can select from the tree or directly in the model itself all your models of the fixture. You can define a name, and again you can define the fixture mounting coordinate system and the part mounting coordinate system. Now what is very interesting With the release of 2022, we announced the associative coordinate system. But how this works now with 2023 in combining with a fixture. So in this example, I'm going to define only the fixture mounting coordinate system, which will be here at the bottom. And let's see how this works. So I will pick on associative face. I'm going to use my top center of puddle box. And I will just pick on this bottom. By the way, I see already for the record, yes, this is all recorded. All examples, you're going to get it after this webinar, of course. And I'm calling to all of you who are watching us now lively, feel free to write some questions, because after each of the application, I'm going to answer all your questions that you have. So I pick on this face. As you can see, it becomes green. Green means we are connected to the surface. I'm going to change the opposite. I want to actually flip it. I see here the coordinate system, it's along the X. So let me pick also the X. I'm going to select this one over here so it matches my MAC orientation. And my Z level, I want to put it on the bottom. Probably there are many other ways how I can do this. This first plate is my eraser, if I can call it. I'll just accept it. And what is happening now, you can, over here, I can see this icon, as this was basically exactly the same as in the previous version. So I'll just click OK, and STL is built out of it. I can open the preview, and you can see that my part mounting is there, which is my MAC orientation itself. And I have my coordinate system that we have defined. And this is a new platform for a tool table. Let me just go straight through it so you can see it. This is how the platform looks if you define it, the fixture from the setup. As you can see, I run it from the setup, and this is how it looks. The main difference is there is no tools available here, so there is no chance that you can define any tools from this window. And the very first here is these 6 icons. The very first is associative fixture, as we define it over here. We have 2 main components on which every of fixture is built, which is the fixture body, which can be anything, every 3D model, and the jaw itself. It's a little bit specific element. And here at the bottom, we have predefined templates. So this is easy way to drag and drop, and you already have pre-built the structure. You don't need to think too much. Just select the 3D models, your geometries, and you're ready to go. With that, also here, you only see a table. You don't see any spindles. And on the right, it's pretty much standard interface that we had it in ToolKit. Now, what is the difference here related to a fixture? Now, for the first time, we can see also and manage part mounting. As both of these have in the index A, it means they are associative. Associative means I'm connected to a 3D model. I can in any moment go back to this and reselect any other, change the coordinate system, add the coordinate system, remove the coordinate system, everything would be possible. I will just now accept it. Before I accept it, I want to share something. Part mounting, it's strictly connected to a part mounting coordinate system that we defined, and you are not allowed to change it. It's impossible to change it. You can add more if you want, but this one, it remains connected to a 3D model. With this, you can also rename your fixture, your fixture assembly, and those will be actually seen in the setup. So I'll just say here, webinar Vise. I'm just going to accept it. There we go. So very easy, right on the table, perfect. So this is, let's say, majority of you are going to continue using this way of doing it. Yes, so just pick on the model, you have it there, everything is there. You can now, of course, move your fixture, move your part related to a fixture. I can go also here, I can move it. Yes, so everything is okay. Right, I'm just going to save and exit. And I will, before I leave the associative fixture, I'd like to show you picking on these surfaces for the coordinate system of my fixture or fixture coordinate system was connected to this specific case. Now, there are many examples that I could bring it over here, but I just simply wanted to show you an easy example where I put this distancer here. And let me show you how this updated fixture now works. I would, in this case, change the distance here to something to be noticeable. I'll just put it to something pretty small. I'm going to update. I'm going to do an update of my fixture. So definitely this is my new fixture. You have a settings in SolidCAM that this goes automatically, like we are going automatically to check if the fixture has been changed, but there's also a manual way. A manual way is by simply going into Setup, do a right click, check synchronization, and then synchronize. But there's also another way where we can go to an edit. And for this purpose, I'm going to open Machine Preview. I'm going to zoom it here. And you have now a new option available by right click, check synchronization. And you may see the traffic light in the corner has been shown, meaning that there are differences. Now you can just do right click and synchronize. Pay attention that the new STL has been built, and now we are maintaining this coordinate system. And you have nothing to change. Everything is automatically updated. This is extremely handy if you are oftenly changing your fixture or during your toolpath programming, you notice that some of the jaws close cannot be at the specific position. You want to move them around. This is the way to go. Update it, go back to SolidCAM, check synchronization, and you get updated. Perfect. Now, well, this is what we used to support, not what we used to support. This is what we supported also in the previous versions, but let me show you now building the database of Chucks, Vises, and Collets, and much more, tombstones, anything that comes to your mind that it's connected to a fixture in SolidCAM. So I'm going to hide, in this case, the fixture. And in this example, I have prepared this Vise. It is pretty much standard Vise that can open from 0 to 310 if you're using this particular jaws, and you can flip and you can get a little bit more stroke. So let's see how to build this in SolidCAM. So for this example, I'm going to open, let me see where I put these. So I have this folder, and I have prepared it for you some Vises. And in this example, I'm going to use this. Let me just copy this path. I'm going to open it and open. This is the exact one that you've seen on the web page. You can download them. It's so easy to do it. You can just go to downloads and just download. You have download the CAD. Many fixture manufacturers are providing the 3D models. So this is actually going to be easy. And let's just analyze it for a moment. First, what you can notice is that this particular Vise comes without jaws. Now, why is that? Because if you notice, I can go here and accessories. You can see that there are different jaws that can be installed. Even the soft one with a let's can call it calls, something with replace it here insert. So there are many variations that you can use, and therefore they are providing this particular 3D model without jaws. But what is important that there are two positions. One over here, this is a fixed position. This is not movable jaw. And there is another position, which is this component over here, that it's actually moving along in linear motion, and its position is stored over here. Let's see step by step what are the coordinate system necessary in this case. First, let's define this in the middle. So I'm going to create a sketch. I think this will be just good enough. I'll just create a straight line. I think I already have actually here something. Maybe I even didn't need it. But here we go. So this is my point that I'm looking for. I'm going to define my first coordinate system. This is a boring part of it, but trust me, building the database with very well-defined coordinate system will help you in making this to have a Lego effect. And I'm going to define my coordinate system as point over here. My x-axis will be along this line. My y-axis will be along this line, and my z will be on top. So this is my coordinate system orientation. It doesn't have to be like this. You can also rotate the x to go in this direction. If you have 3 axis mill machines, if you want, once you load your fixture to be in this direction, you can also flip this coordinate system as well. I'm going to do a green check mark here. I'm going to rename this to, I will call it main coordinate system. The next one, it's located over here, and another one over here in the middle. So I'm going to just quickly define a point and another coordinate system. This coordinate system will be exactly the same rotation. Let me reselect this entity. Along the Y, and then along the Z is just this over here. So exactly the same, nothing so special about it. I'll just accept it. I'm going to call this linear. I'm going to call it just linear. So it provides the linear motion, right? And the next is I'm going to repeat the same process for this point over here. I'll do it a little bit quicker, and I know that GoToMeeting can be a bit choppy, that you don't see it, but you will get a point. I'm going to select everything is the same, but with the main difference that I actually want to flip my coordinate system. Why I want to do that? I want to make sure that this is actually flipped. So it goes like Joe's from this goes away from this one. So if you want to use the same Joe's also over here, then you better flip it. So I'm going to just flip this, and X now goes in this direction. The name of this, I'll just call it Fixed. And I'm just going to click on rebuild icon, and that's it. These are the 3 coordinate systems that I need for a Vise. So let's export those things. I'm going to hide this body over here because this is going to be exported with another model. Everything that you can see here is the main body. So yes, you could have screws, maybe more complex wise. I'm always advising that usually, you know, the fixture manufacturers are providing some kind of geometry optimization, so it's not so heavy for the simulations. But you know, guys, if you really, your fixture is really detailed unnecessarily, it is better to, you know, don't make your fixture more complex in geometry than the part itself. To try to optimize in such a cases the geometries, it will increase the performance in the simulation, but also the file size will be much smaller. So managing of huge libraries will be much quicker. So let's do a save as. Where we are going to save this. This is going to be stored in your 2 libraries. Now you probably all are familiar with this from 2021. This is your default folder. You may change it, yes. And I'm going to just in this example create a new folder which we are going to call webinar fixture. Inside of it, I'm going to create like it's a Vise, and maybe this one will be called 160, 480. And over here, for this particular Vise, we are going to create 2 sets of different Joes, okay, for this webinar. And I'll just make a Joes here, and I'll store here this main body. So I'm going to delete this. It is the number model. You don't need to have it. And I'm just going to call this body. Change this to STL. I'm going to click on option. Like a standard way of we had in tool assemblies, we are going to use, in this case, save all components of an assembly into single file, because here we have a multi bodies. Do not translate STL output. This must be checked. And now here you have some resolution option. This is not so extremely to be, you know, perfect. Like 0.1 intolerance, it's great. So I keep for all my fixtures, coarse resolution, that works great. You can go to the fine, you can do anything as a custom, coarse works pretty well. Just don't forget over here, the output coordinate system. This is extremely important. And I'm going to select main coordinate system. Click OK, body, everything is okay. I'm going to save, that's it. I'll now open another project. That will be, let me just go to my SolidWorks, and I have prepared the jaws. And here I have two sets of jaws. As you can see, this B in the kind of index, this means it's movable. This F means it's fixed. But I double check, triple check geometry, they're exactly the same. So it's just a name. So we are going to export only one of these, one of this one and one of this one. Just change and rename and copy them. And here it is. I'm going to copy, open it in SolidWorks. And here I have it. Now for this model, I already, you can see it over here, I already prepared the coordinate system. This is for my fixed. So in the jaw, in the Vise, as I have it oriented there, it looks like this. So another will come over here. Okay, you can already guess it. So this is the orientation of the coordinate system. You can see that I follow the same orientation, XZ, okay, in this way. I'm going to save it as. And in order to not jump all the time from two libraries to this one, I'm going to copy this path over here. Jaws, copy. I will need that for later. Now just jump to the two libraries. We create this folder, Vise Jaws. Perfect. I'm going to remove all of these. I don't need it. It's 160 with this type. And I'm going to actually call it like fixed. Or maybe, yeah, actually this works pretty well for me. STL, I'm going to call it STL. Let's go over here, pick the coordinate system, everything is okay. Let's save. There we go. Perfect. I'm going to open that. This will be easy to do. I will just open the same jaws, and I'm going to just paste it. This is the same jaw, but I just changed the file name. All right, now let's open another one. It is more complex, absolutely. So now let's see, this is now coming handy. Let's see, I think I can do like this and enter. Yes, perfect. So it's this one over here. So let's do open. The jaws is already here. As you can see, it will be oriented as so. This is, let's say it has all the details. I didn't turn off all the details. You don't have to. So for this webinar, I'll keep it. You can also consider that I check it. The file size of this jaw, it's about 200 kilobytes. But if you just make a simple extrude of these, you're going to get almost like 40% of size reduction. So I think it's maybe worth to optimize those things, but it's not necessary. It's not really necessary. You have to do that. So I'm going to do a save as. I'm going to repeat the process. So I'm going to open the two libraries. I'm going to place my jaws. It'll be called like so. And yeah, also STL options. And now I think this time it is automatically selected because the name is the same. Just going to click save, click yes. Again, just jump this and I'll paste. This is my finishing. There we go. So exactly the same, but the different jaws. There we go. Perfect. So I have my assembly done. So how to proceed? There are many ways to proceed, but if you're familiar with SolidCAM 2021, You can do this in many ways. You can go to Tools, SolidCAM, Toolkit, create a new Tool Components library. You can do it also from the ribbon on the right side, or you can do it even from the project. It really doesn't matter how you do it. I would just do it in the old-fashioned way. Just create a new Tool Components library. And I have here some that is predefined. And I'm going to show you that the first thing that is different, you can see now you have a fixture folder. And now, of course, with everything, now we can define those two. Right click, I will import the structure. The default library is opened. I'll just click on the webinar fixture, and he's going to automatically create all of these. What I see already now I'm missing, I forgot to export the linear one. So I'm not actually going to leave it. Oh, I could forgot that. Perfect. So let me just show this component, and I'm going to hide others. And I'm going to export it with a linear coordinate system. So let's do that quickly. I will place it there. So Vise, and it's going to be here. I will go STL, maybe I'll remove this. And I'll maybe just click on this, I'll get the name and change this to be linear. That's it. Options, make sure you change the output coordinate system to linear. That's the main stuff. Click save. Yes, that's it. I can close all of these. I can save this. I can close this one even. So SolidCAM, Toolkit, Tool Components. I'm going to do it a little bit in a different way where I'm going to maybe save this just in case to not. I'm going to call it webinar fixture. Okay, this is the tool components files. I'm going to webinar fixture to Joe, not add a Joe, but convert to Joe. And I'm going to keep it. I'll just save it. So for the 3D model, there is no basically difference if it's a Chuck Joe or prismatic Joe, and I have the issues with another one, so I'm just going to keep it. And in from here, you can, what is the delta that is necessary? You can see we have here two, that is one fixed, one movable. All of them looks exactly the same. We have here the main body, and of course we have here the linear body. Now for the main body, what we have to do, we need to define, besides of this coordinate system, we need to define other two, which you can define if you just open, I'll just open the recent assembly in the background. And over here, I have only one joint. So this joint is going to be called fixed jaw position. And I'm going to create another one that is linear jaw position. As you can see, this linear has an axis on it. I will go to the axis data. I'm just going to call it linear. It has all the properties of the axis. It is a linear type. It is along the x vector over here, as you can see. And my minimum limit is 0 to, I think it's 316. Let's see it here. 310. All right, so 310. So let's stick to that. So you can put a real axis limits. I'll click OK. Perfect. Now for the fixed jaw position, I'm going to click on this calculate orientation and position. Please make sure that your assembly behind the scenes is open, and you click on this button. Here you have the main coordinate system, and I'll click here on the fixed one, and I'll hit apply. You will note that automatically the coordinate system is applied over here. Click OK. I will repeat the same process, but with a different coordinate system here. So the main coordinate system and also two linear one. I'll just click apply, and Here we go. All looks good. Perfect. So with this state, let me just save and exit. I go to my program, and I can now, yes, you can define everything inside your setup, like step by step, but you can also predefine the assembly. Both ways are possible. I'm going to do it from the setup and later just export it. So yes, guys, we can go SolidCAM, new, and for this demonstration, I will do it in different way, a little bit in comparing to the previous. I'm going to save this as, just to have it in our database. So you can see that this is now assembly. So I'm going to call webinar fixtures, and I can say also like assembly. Click save and just leave it. So this time I will just open it differently. I will go to the setup. I will select here to none, and let's pull it from the library. Let's define it for the library. I will take the library. I have here the webinar fixture. Let's do it. So I have my body. I'll just drag and drop. I see it here. I'll take my linear, and as my linear body is actually on, what is it called? It's the first jaw, so I'm going to change my linear jaw position. So here you go. Now it's in the correct, you can see it. I can now go to the jaws, and I'm going to use this one. It's fixed, so I will just drag and drop to this. It is over here. And another one that is movable, it goes to the linear. So all looks okay. What you can do now is the following. There is this quick access where you have this component access. By default, it will be at 0, but you can predefine the values also in this axis data dialog. And you can set the value to 310, to the maximum position. There you go. What is still missing? We are missing the part mounting point. So if I now just click, I want to do it, you're going to get an error message by saying, you don't have any part mounting defined over here. So please do a right click and define add part mounting. So I'm going to do it based on my main body. You can do it to any other. Right click, add part mounting. Part mounting is over there. And for now, you need to do this kind of manually, but we will have other ways as well in the future. I'm going to put here 119.5. My part mounting will be there. So what this basically means that my Mac is going to, he will store my part something like this by default. Gotcha. So I have my fixture. I'm going to do a green check. I can see here the fixture. You can also rename this. I will open this. And there we go. I can also hide my machine. And let's see how to go from this point over here. This is, guys, new. How to really move this. And it was always problematic. If you want to really set up this, you can always use these values and move it around. Yes, but it's not so convenient. Therefore, you have this new option, calculate orientation and position, where you get this dialog, where on the first here you have a filter. So the filter itself will give you an opportunity to select the faces, edges, the point, and here you are having a different match type that you can perform. In this demonstration, I'm going just to click on the faces, where I'm just click on this, click on that. The faces are listed. Let's do match. So I'm going to now do the following. I will just delete this selection, and I can say I want to go from this point, and maybe for the bottom of the part. I'm going to hide my stock, click on this, and just hit it. There you go. You can now, of course, put a distance of 5 or maybe 2, and you can also flip it. So you have here option of flip, and it's going to flip. Click OK. There you go. And as we have all the details with the moving of linear fixtures, now you have a new option that is auto close on stock. Auto close on stock will take the middle of the coordinate system, analyze the job itself, and it will try to find the stock available here. So there is an option for the auto close on stock. As this stock is exactly out of the fixture, there is also another way, auto close on target. This is very convenient, especially for the mill turn. And there's also an option of set position. With this, you basically finish the setup. When you have now this in the library, it's just a matter, pulling up from the library. Just accept it, and that's it. So let's see how to do that. I will just have an exit. I can now, even in from the toolkit, I can see my station. I can export to my TLS that we just created a few moments ago, and I will drop this fixture. So I have my storage, I have my fixture, and just put it there. I have it in my library. All is there. So you can now, I will save and exit. And I will just unselect this. And let's do it again. But now, because I have it in the library, let me show you how to do it. You go, you open your assembly, you have your webinar fixtures. I define this one. Should be this one. Seems not, but let's see. I hope. Interesting. Let me try again. Maybe I will just reopen the. Oh, no, it's not there. Pardon for these guys. Let me try to reopen this and try to load it again on this. Now let me see while this is opening. There are tons of questions. Okay, can you please? Okay, I see. All right, a lot of questions there. Okay, I'll try to answer, guys, everything on this. Do I have something in the storage? Yeah, it's here. Okay, so let me just drag and drop. There we go. Okay. First question there is associative with toolkit inside the setup. So what it does, there is, guys, over here associative with toolkit, as you can see it over here. This checkbox, when you define this particular vise, this is a piece of assembly, and you can reuse it for another setup if you want. True. I can make a different jaw positions. True. But if you have second setup, so let me go 7 exit. I will go to the toolkit, and I'll open my fixture, and you can see here I have my position. If this position, because it's associated with the fixture, I can now move it in any position. I think it's more obvious if I move it along the y-axis. So just remember that here I have the 100 value. I'm going to accept it. And you can see now that the values that I put inside my toolkit is there, which means it's associative with the toolkit. Now I don't have to uncheck it. The only way to uncheck it is to create a new setup. After, I'm going to pick the same one. Is it the same one? Seems, maybe I need to save it and to, is it the same? It should be the same one. If it's, but I need to use another Mac, of course. and I will pick this one. And as you can see, he is already picking the one that is available and defined, but you can have now this checkbox and you can uncheck it, and now you can change to any value. Here I will go to the minus 100, and I'll just do 7 exit. You can see that now those two are unrelated. So here we have 100, this is minus 100. And of course, you can change also the values. There's another question popping up. Is there a wizard for fixtures? Yes, so you can go to the toolkit. Okay, guys, so I did this step by step, showing you how to do it. I'm doing it this way, but you can also go over here and you have an option import from CAD. Let me just close it and open this one, and you can define it like so. We'll try from here, tool, and I will do tool assemblies. And you have here, guys, generated fixture as well. Another question, let me see. So there is associative fixture, how to do it for the second setup. It's always related to a Mac 1. Okay, yes, this is related to a Mac 1. We notice it. For the convert, we did it like so. But for the SP2, this is going to be pair your selected Mac. Okay, pair your selected Mac in the setup. That was actually a good question. So sorry, unfortunately, Grant, this is actually not available in SP1, but it will be available in the SP2. Can you save it and as another fixture and copy fixture? Oh, of course. You can save it and copy, and you can do now anything you want. You can also, I didn't show this, but I think it's pretty good. I will just delete this one here. I have found 2 different Vises. So you can now go to your assembly. We have defined it over here. So we have a different jaws, right? So I'm going to open. Click on this, I'm going to replace those jaws, right? So I have used this that I can consider like a soft, and this is the fixed one. So I'm going to take it, and by the way, good recommendation, take it on the icon, not on the text. There are some different functions for that. So I hold the Alt click and just replace it, and the jaws just replace it. Then I'll do same for the movable one. Just hold it, Alt click, Alt. Did I replace it the same? Oh, this is the fix, and this is the moving one. And I haven't. I think it's absolutely. Did I? Let me just. I think I didn't. I forgot to copy it, or so. Let me just. It's one of on top of each other. So I'll just take the fixed one and place it there. So I have now completely 2 separate. I'll just accept it. I will open the preview. Let me set up this. So this is movable. Let me hide the machine. You can go on this calculating the rotation. I love these guys. So you can go, you can pick on this, just clamp it. Maybe it will be if you have also undo button, because you can click on this. Let's make it there. Match. Then we can go like go here, match. That's it. And now you can just close on stock. You can also now move it here, close on stock. You can also, guys, go to assembly, and you can, for each individual, you can flip it. So over here, there is a flip button. You can also do it for another. So you can choose, you don't have to flip both, okay? You can get a different stroke for this. I'm not going to move, actually, I will just manually move it for a little bit. and move it here, just manually. Just close it. So we can also close it here, and move it a little bit up, and so on. I think it's a great feature. It reduces tons of time in the setup. With that being said, there's more questions. May feature to other side of the part, define the fixture as you have always done. I didn't understand that one. There are so many, okay? We are running out of time. I will try to answer it I will try maybe to cover it with the mill turn part. I'm going to open another pod, and I like this one. Probably you've seen it many, many times before. It's a standard one that I used for the demonstrations. It's the standard 2-channel NTX 1000, where I've used also this one for a presentation in Istanbul. And I have, for this example, the Shanks Rota S Plus 2, where I'm going to show you how you can define a chuck. So with this, let's go towards the toolkit. I have plain note that I don't have anything defined. Let me show you the machine fairly quickly. Here we go. So this is a machine defined without the chucks, okay? There's nothing defined on the station. So I'm just going to click on the Open Toolkit. And let me show you how you can do it. I will open Machine Preview. And I will just take the chuck, drag and drop. There you go, guys. So I have a chuck that is defined, that has 2D sketch defined. You can change the values. Everything is now, what is good about it, everything is live. I can go to a Joe. I have the part mounting as well. My part mounting, let me just show you this. So my part mounting is now on the face of the table. And what we make a real big difference. With this mating, guys, it's really not, it's kind of operator friendly in this case, because for me, it's now completely not important if I have both options to measure part stick out related to a face of the chuck or face of the Joe. So over here, I have just a simple three chuck Joe. I'm going to click on Joe page, and this is something that you are probably very familiar with, and there are tons of improvements in this one too. And I'm going to go through these parameters. So I have a thickness, number of steps, and this is a new feature. So now either the thickness and every of these parameters, guys, they're dynamic. What means dynamic? It means that if I'm changing something, you can see that lively, we are changing the values. Now, not only that, but in the past, we never had an opportunity to control the last two steps on the on the Joes. So now you can change any steps you want, also the height of each element individually. You can also now do a number of steps to 1, maybe 2 or 3. It's really up to you. What is the most important when we are talking about the chuck Joe is that you have to define them in the XZ plane. And this is hard-coded rule. As you can see here in the plane, this is hard-coded just for the info. Over here at the bottom, we can do clamping data, where you have an opportunity to select the number of Joes, 2, maybe 3, 4, 5, 6, and so on. Also, we do have a clamping position reference point, which is the small point in the coordinate system of the joint. And you can move it around with the scroll wheel, okay, as you can see it over here. Or you can use these arrows, and it will snap to the very first point over here. You can also flip the Joe, but also you can use open section viewer. I'm going to show that later what it is. So that's regarding to the fixture. But let's see how actually we can now define the chuck. So I'm going to leave this, just exit, and let's open this. So I'm going to open the 3D model. I think it's much easier to define the chuck than the Vise, to be honest. I will go to my fixtures, and I have prepared this assembly. I think this one, it's assembly. There we go. I'm going to show it. Displaying, shaded. Okay. So I have prepared it. There's nothing so specific. Actually, maybe I could just open the original one. In the original one, guys, there are 3 jaws. And for the export, we don't need them. Basically, it's just they are there, and I just physically delete them. So everything is kind of ready. So I have not done any more jobs than that. And here I have the chuck coordinate system over here for the face of it, for the easier export. And also what I have defined, let me just hide this. I have created a plane in the middle of this jaw. And what is the rule? So the rule is to create a coordinate system that it's like so. So this is the X, so this is the Z. And you don't really need to create it over here. Like I created an intersection of these two, but you can also create it here or here. There's no really a rule, but if you really want to get a correct point of reference point, which is important in the case you want to do internal clamping of the jaw or so, then the rule is quite simple. So to detect this point, we first go along the X, we find this line, and then we try the first Z. The first Z geometry that we picked, as in this case, it will be this point over here. So I have made this kind of helping lines just to detect this joint, so it's easier for me later. But you will agree with me that this is nothing so special about it. My geometry is this, so I'm going to hide this one, and I'm going to unhide this body here. And let's just export it. So I'm going to do a 7S, and I'm going to store it in my two libraries. The folder that we have, let's do Chuck to do and the name itself, I will just STL. This all looks good. Or just make sure the options. When you go to the options, output coordinate system to a Chuck. All to the positive, single, save. I'm going to maybe reduce that, I don't need it. And just hit save. That's it. And the last step is just unhide this one while all other, oh, let me do it like this. It would be faster. So only the jaw, save as, and the same folder. We create a jaw folder here, STL, options, jaw coordinate system, click OK. And I'm going just to call it Joe. Save. All right, so what is I'll save it, it's okay. So what is the easiest way to do it? There are a couple of them. And maybe it will be too long for this webinar, but anyway, I think it is very valuable that you know how this is done, guys, behind the scenes. I will just do it the most easiest way. Is you use the template, and I'm going to take a chuck. The template is there, and I'm going just to select 3D model and pick up these STLs. So webinar chuck, take it. Of course, you can save this one over here. What we have here is now that I need to care about the jaw position, and jaw position is actually on this surface over here. So you can just take the simple measurement, which is exactly into 16. So my part mounting, just move it here in my jaw joint, move it on the 60. okay, this point over here. And for the jaw, I'm not going to use my parametric data, but I will use the 3D model. And again, I'm just going to pick this jaw. There we go. And there you go, guys. Everything is there. You can see now slightly that here there is this point. It seems really important. I see that in the chat what this reference point means. This reference point says that, okay, this is going to be my clamping diameter. This is control point. Maybe for somebody who didn't see that, I will just show it. So 45 means that it's controlling this point. Now over here, I can click on this. And if you open the section view of this jaw like so, and now I can say other points as well. So if I click something over here, you will see that here the point will be visible, and you can click OK, and now this will be the control point. I'll just put this on 0. I will need this later. I'll just select it, and I have my fixture. Here you go. You can also, it's quite handy, guys, if you use this focus target. I'm going to zoom it in here. What I can see, I make a mistake that my part mounting point is here. So let me just modify that. My part mounting point, I would like actually really to be in the face of the spindle, but you can also place it somewhere else. So here it's 81.5. I can easily put it on. I'll leave it on 81.5, but guys, look, it's not important because if you put it there, you can see the part will be there. Your Mac will be matched. You can go your part, move it, okay? You have your open position, and this is, I think, maybe informative information. We are working also closely that we support open and closing of the jaws. This is going to be in some of our next releases, and which means everything that you see in the toolkit, everything what you guys define in the toolkit, it means for us open position. And anything that you see here in the machine setup means closed position. And in the future, when you use open and close from your MCOs, you're going to see open and closed positions right from this data, from the toolkit and from the setup. This is my clamping that we pull it from the toolkit. And now you can just close on stock. And we automatically close on this specific stock. What you can do also, you can click on this diameter and you can click on any of these entities, guys. You can also do that. It will close on this stuff. What you can also do, you can use the option of close on target. This becomes very handy when you have a back spindle and you know that your material is going to be machined over here. So you have no stock, it's directly on the target. So that's a useful feature. But you have, guys, also another option. And this option, it's called set position. And I'm going to show you how to use it with a different example. I'm going to open again the toolkit. And in this example, I'm going to switch these positions and let me try to clamp it with this over here. So I'll change my reference position to, I think this is the one. So it is over here, you can see. I'll just accept it. I'll click OK and accept it. Right. One thing I forgot is to increase the open position. So let's say 45 was before. So we can keep it on 45. That will be fine. So here it is, 45. Now I can do this. So I use the advanced. You click on this and you say, what is my stick out? So you can stick it to this. Done. You can, guys, also say, what is my stick out from the, not from here, bottom, but from here to here. So you can say, oh, my stick out, it's 70. Here we go, it's 70. So it's so easy to now do these things. I can put here 150, and I can say delete all. I can now say I want to clamp it there. Click, click, match. and close. So it will close. You can also now move the part and close on another surface. But of course, these values now are related to the bottom pick there. So I think that's straight for all of you. So tons of possibilities, really, a lot of stuff. But this was the way how I defined this fixture when I had let's not call it symmetric jaws. I will call them equal jaws on all three sides. Now there is a question like, is it possible to define three different jaws? So let me show you how to do this, guys. So I will just open a toolkit. Let me show you how you can do this from the scratch. So not using a template. So I will just pick on none. Now, of course, it is clear that once you define this chuck, I'm just storing it in my assembly and just pulling it out. There's another question. Can we predefine this for my machine? Yes. You can predefine any of your fixtures. It works exactly the same like for the tools. You predefine 2, 3, 4, 5 vices or chucks. You can easily then just pick them from the setup. Great question, actually. So let's see this step by step. So guys, we are going towards the access control. In the invitation, I have said that I'm going to talk about access control. And before I show you on the chuck, I'm going to tell you when this is useful. First, it is useful in exactly when you have the cases that are complex chucks where you want to, let's say, define the three different jaws when you have a specific profile on which is different for each jaw, and you want them to be different. Of course, in that case, these jaws cannot be patterned. Okay, but each individual jaw is defined with a specific what is it called? With a specific joint. Okay. One thing I didn't show you. Oh, I'm embarrassed a little bit. There are so many things, guys. Sorry. Yeah, I agree. So let me bring back my fixture. Set position. I forgot to show you the set position. Look, as I said, I don't want to make these 3D models like to be optimized without these close and stuff. I really took these 3D models and just use it here. And this auto close, guys, it really works in 95% of the cases. When what I tested, it works good, but we will still optimize it, of course. But there will be some occasions where the automatic auto close will not work. There will be. And in such a case, you can always use something else. So you can go over here. I will just clamp it. So I want to clamp it with this point. So I go click over here and you have the set position. Now the set position looks exactly the same as matching, but this time we're actually moving the axis of the fixture. So you just click on any entity, click on this, and just close it. Or you can say this, any point, click this, close it. So you can use this in any case. So this, if auto close failed for you for some reason, this will not fail you. Okay, so let me go back now to what I start. So how to do the chuck for the three jaws when they are different. So I take the fixture and I'm going to call it joint 1. And for this fixture, I'm going to take a 3D model, and pick the same one that I used. There you go. All good there. And connection. So I'm going to set this as my linear axis. And my linear axis, it's set towards the X. Okay, so I'm going to make my axis data. This is along my X, and this is my joint 1. I call it joint 1 axis. You can also set this minimum maximum for now. That's okay. I'm going to copy this, paste. And with this one, it's going to be rotated 120 degrees. Copy, paste. This joint 3 is going to be rotated 240 degrees. So you need to know exactly how many jaws you actually will have. And now, of course, we need to change the axis data. What is very nice about it, maybe you didn't notice, when I change this rotation to 120 and this one to the 240, SolidCAM automatically calculates for you this axis vector. And the very first one is the one that you need. So simple. I click on this, I click on the axis data, I click, and I click on this. Now, this will be my jaw 3, and this will be my joint 2. Okay, so I have my 3, all of 3 are linear, and I can now put my jaw. I can just drag and drop first jaw, and let me show you how it looks. So I'm going to make an offset. I need to put some offset. I think it's over here. The distance, it's 60. So all of my Z on each joint, it's 60. And this one is 60. So I have here my jaw. I'm going to change it. I'm to the 3D model. And others will be different. Jaw, and I'm going to select this one. There we go. So this one is different, but others will be just parametric. So I just drag it. This is parametric, and another one, if I drag it, it will be parametric as well. So obviously I have 3 different jaws. So this can be parametric, this can be 2D, this can be 3D, different profiles. It's up to your imagination what you want to do with it. But now you can also note, if I go over here, I'm just going to accept it. Oh, I have no part mounting. Let me just define it quickly, part mounting. And it was on, I forgot the value. My brand doesn't work for it. So it's 81.5 exactly. I'm going to accept it. And one more thing here. In the quick axis now, guys, you can see all these 3 joints. As you can see, I can now move each individual one. What I can do with it, how to make them together. You maybe also know that there are many vices that are symmetric. You see many 5-axis vices. They have options for like symmetric. Rotating and moving linearly one, another will also move. This is exactly this case. You can have 2 different directions and so, but how one axis can move another one. And we're coming to a point when this feature in SolidCAM is called axis control. You can access to an axis control from the joint. Currently, temporarily, I would say, we store it here. In many occasions, you will not need it, but in the occasions when you want to do really something advanced, you can do right-click here, and you're going to have an axis control only in the cases if you have axis defined here. If you don't have any linear axis or rotary axis, axis control will not be available for you. I'll click on the axis control, and this is how everything looks. So on the top, you're going to see the master axis, and each of these master axes can individually be moved, or you can set the slave axes, which are slave to the master one. And we can choose any of these. And for me, maybe this one, I'm going to say, okay, this is my master and all others are my slave. So in this example, I'm going to add and say, hey, I want my J2 and J3 to be my slave axis in the ratio 1:1. There are 2 different connections. You can do a different the direct gear connection, or you can do it also as a function where you can put the function. You're pretty familiar with this interface from the earlier version of SolidCAM related to the MCO. But the gear works great in this case. I'll just click OK. And now you can see that my J1 has the values the same as, or let's say J2 and J3 has the same axis as the J1. So I can now work on these guys. So this is how you can also support symmetric jaws, and anything that comes to you, you can go to your body, access control, and play with it. And this basically covers my webinar. And oh, there are questions. Let me see a second. Okay, the first question. You had a database of fixtures in Istanbul. Is it? We didn't get it from the SP1. Okay, so yes, I prepared a very nice library of the Vises, Chucks, Collets as well. Mostly I used one of these in this example, and those will come with installation with the SP2. Great question. Oh, there was a question like, why don't see axis control and orientation here on my PC? Okay, guys. So everything what you see here, probably one of the reasons why I received the question, it's the access control and orientation position, what you've seen in the setup. It's available only currently in the development version, and it will all these come with the SP2. Okay, this is the main reason behind it. So everything what I'm showing you here, mostly it's usable only in the SP2 versions. Okay, there are many that you can, of course, pre-build the databases. You can define the joints. You can work with these. Okay, but like access control will not be available. The simple one, yes, but this one over here that you can see in front of yourself now. Another question, what is the add virtual access? Okay, good question. A good question. So, you know, there are occasions like, I'll click cancel on this, where you want to make, let me just delete this one over here. When you want to define it as a regular chuck, okay? Or you want to add a virtual axis that controls all these three that I have defined. Maybe I could show it on this example. So imagine the virtual axis is the master axis of J1, J2, and J3. So I could have everything under that control. But let me show you how other ways to use this, even on single linear axis. So I'll just go to the axis control again, and I have add the virtual axis. What we are going to do here, I just click OK. But one more thing here, I forgot. Let me do a pattern. I want to show you also this. So I will going to shift it for 120 degrees. Recreate. So this is going to be, let me just delete those. There you go. But you can now see that I have my J1 axis. It's moved. But if I put here on 0, this is exactly the 0 diameter. But if I move 1, or let's say 5, this is 5 in radial, but this is actually the diameter of 10. So how you work on the diameter in this case? This is also where the axis control can help you. Go to the axis control, and let me just delete this virtual axis. So you go to the axis control, and in the case you have only one linear axis that is patterned, we discovered that it's a chuck. If you click on the add virtual axis, we're going to say, hey, this is a potential chuck axis. Just there's only one here, and just click set yes. It's a clamping dimension. There you go. Now it works differently. So you go here, clamping dimension. If you go over here, now this works like diameter. Perfect. Let's see other questions. I have tried. Let's go. Inside ToolKit, is it possible to set the value of components axis linear? Could it be possible to use predefined axis limit? Absolutely. Any axis limit you can predefine, And if you go, for example, here I have the clamping dimension. So you can, if I edit, you can predefine the position, but you can also set the limits. So for instance, if I put here from 0 to 50, if I click OK, and if I move it more than 50, you're going to get this information about it. Next question, autoclose function and cut connections are available in shop floor editor? It's a good question, Frank. Sorry, I don't know. Honestly, I didn't try it in the shop floor editor, but I don't see the reason to not have it there. I'm pretty sure it will be there 100%. Great webinar. Thank you, everybody, guys. Let's move forward. If I have a custom fixture, will you made in SolidWorks and there is a design change, you alter SolidWorks fixture model with carry over into a CAM? Okay, good question. If you change your fixture CAD and this CAD is selected as associative, it is going to be changed in your design, in your specific CAM part, okay? But if you are having your CAD and you want to, let's say that you save it into your library, you know, you guys, you need to be, it's the same functionality as we have it for the tools. Everything what you export in your STL database, it is going to be used as actual. So yes, if I, for example, have a revision of these joes, and let's say there will be another joe with maybe hole over here, and you overwrite that STL, yes, it's going to be loaded automatically, the new one. Why do you delete every relation after position inside dialog for workpiece? Shouldn't, okay, good question. Why I have, let me bring to this position. I have it here. Yeah, I have it this one, so I'll just accept this one. I need to delete this and use this one on the main spindle. So the question was why I have to always delete. It's a good, so when I use this feature, why I have to always click on something and delete and put the value and they are not deleted. So when you do a mate, so let me just, it's a good question, but look guys, this is a very first revision of these fixtures. We are always open to, we are listening to you. If you feel that there are one click even more than necessary, we're going to remove it, no problem. So for instance, I'm going to click on this, open this dialog, click on this, click on that, and do a mate. As you can see, when you do a mate, sometimes you are not sure about if you want to keep it or not, and you can put the value here. So we allow you to, for selected entities, to perform additional changes. So you can go 50, you can flip it, you can undo it. In the case you are fine with that, you just delete it all. I agree. I already get the that we can have a green check mark here and maybe do it a little bit different. We'll consider it for the SP2. I guarantee you that we are going to optimize it a little bit, but so far not so bad. Another, if we have yeah, this is what I read already. I see this already. Perfect. I think this was all the questions. Guys, thank you very much for your attention. Sorry for disappointing you. You have many things of these. Yes, will be only in SP2. I'm looking forward for it. Please give me your feedback. Feel free to write it, the emails, comments, anything that you find like complicated or like room for improvements. Please let us know. We will be able to study that for the SP2 release that's coming in, I suppose, less than a month. And yeah, that will be it. I hope you enjoyed. Sorry, it was a little bit longer. Take care and have a great day.